Will he say it again? Will he start from the beginning? Of course he'll start from the beginning. Video 1, the point of regression. Okay, one of the points of regression is for us to explain the variability in our response variable using the explanatory variable. So the very first thing that we need to do is talk about the total amount of variability within our sample. And that's what we're doing with the SST. How far does each point deviate from the mean of the response variable? So in this plot, how far does each point deviate from the mean of the response variable, which is y bar, this point, this line here, okay, for each and one of these points, okay? So then what we then do is find out that value is 387, right? 387, that's the total amount of variability, okay? We then use our explanatory variable, study hours, to sit there and that's our attempt. We're going to use that for our attempt to actually explain the variability in the actual quiz scores. So the actual regression model, the predictive value, is what we're saying, okay, this is our best attempt based on study hours to predict the quiz score. So with that said, that's what we did in video 2. Video 3 is now to discuss the unexplained variability. How far does our data point deviate from the regression line? Okay, for those values, yi minus I hat. Why did it? Okay, it doesn't matter. Okay. So again, okay, we have our data. There's no different here. Okay, again, the regression line is already done, so that's fine. But now we can, this video might be a little shorter. Now we can actually visualize how far each point, how far does each point x comma y deviate from the regression line. Show visuals. So actually I'm going to say show true, but I'm not going to run that yet. Okay, I'm just going to say what I just said, but with the data in front of me. All right. So boom, copy. Okay, let's run this again. How far does each point deviate from the regression line? It's purple from this red line, it's purple from this red line, it's purple from this red line. And so when I add this comment, show residuals equal to true, it's not going to have a black line that denotes this distance between each and every point in the regression line. And that's what we're going to measure. We're going to find this distance squared, 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 and sum all those values. And that's going to be my sum of the squares residual. How far does the regression model deviate? How far does that's it too. How far does the regression model deviate from the point? So how far does the point deviate from the regression model? Okay. And so here, let's go about doing that. We're going to first start off with the model, which we already have, but I'll still do it. We don't have to do this again, but I'll still do this here. Model lm x or y tilde x. Okay, so I'm not going to show it because we already did it earlier. Okay, so we have predict values. You don't really have to do this, but I'm still going to do it here. Predict values, predict on the actual model. Okay, so nothing's going to change when I run this. Nothing. Boop. And then what I'm going to do now is calculate the residuals. Okay, so how I would calculate the residuals is by taking y minus predicted values. Okay, it's always that order, just by convention. Even though doesn't matter because I'm gonna square this. So calculate all the residuals, boom. Those are all the residuals. And again, if this situation works as well, works here in that if you were to take the sum of all these values, okay, it's gonna be 0. Okay. Sum. This thing's annoying. This is very close to 0. So ideally what I'm going to do is square this. Okay, square and add like I did earlier. So I'm going to take this and say SSR is equal to this, what I just copied. Then I'm going to square within the actual parentheses, with a new parentheses, and square each term. And SSR should be 30 something, 31 point something. Okay, that's it. That's what we see. SSR is 31 points. So this tells us how far does each point deviate from the regression line. Okay, so stay tuned. I don't know, I can finish it. Should I finish it here? Because all the videos are so long, I'm gonna finish it here. No video 4. Okay, Let's do it here. Okay. So let's remember. Okay. This is SST. SST. I don't think I even defined SST, did I? So this shouldn't work. Doesn't work. So go back to video 1. Notes. SST should have been this. It's 387, which I mentioned in video 2. But I still didn't write it. Okay. SST's there. I didn't do SSReg as well. Okay, SSReg should be right around here. SSReg. Okay, boom. SSReg. And then finally, okay, so if I type SSReg, you'll see this here. 356, 387, and then finally SSR is 31 point something, 31.15. Nice, cool, perfect. Okay, great. Okay, so that's our variability decomposition. SST is broken down to 356 and 31. So what we can now do is we can actually talk about some really cool equations, really cool understanding of what's going on here. Okay, so SST is equal to SSReg plus SSR. Okay, that definitely should be an R chunk here. Oh wow, no lights. Okay, good. I'm back. Alright, so what I'm gonna do is I'm gonna put my cursor here and click on this button for an R chunk. Okay, and click on this. And then what I'm gonna do is I'm gonna say SSReg plus SSR. Okay, and then run this. And look, it's 387. Like I said. You can decompose your variability into 2 elements, SSR, SSReg, and SSR. Okay. We can also calculate R squared in multiple ways. The very first way is just take SSReg divided by SST. Okay. We get 0.9196. Okay. We can also do this in another way. Okay, press enter, create a new line, create our chunk, and then we can just do 1 minus parentheses SSR, the sum of squares residual, which is not explained, divided by SST. What is the total variability? This should give us the same value, 0.9196. Okay, and so that's those 2 metrics. Another huge metric that we are going to talk about pretty soon. We haven't spoken about it yet. Is residual standard error. That's how R says it, and it's so annoying. But I traditionally call this standard deviation residuals. Okay, so what I'll do is I'll take the square root of SSR, square root of SSR, sum of squares residuals, divided by N, which is the sample size, minus P. We're in simple linear regression line, so the number of predictors, the number of explanatory variables is 1. So, so that's P minus 1. This is going to give us an error. It's going to tell us that P is undefined. P is not found. All right, so above this, we're going to say P is 1. And that's going to give us our residual sum of squares, 1.973. Okay. So let's talk about some interpretations of these values. This is just telling us the decomposition. There's nothing really huge there, but just for you to know how this works. R squared, that's huge. This is the proportion of variability in the response variable that's explained by the regression model. I low-key should be okay with, or should be okay with you saying it's the proportion of variability in the response variable, the study hours, that's explained by the explanatory variable, or you need to say, just study hours, but that's not preferred in 324. I would want you to say the model because that's SSReg. SSReg is doing the work, not necessarily, not only just the X values. So be cognizant of that. Okay? So that's R squared, and then this standard deviation of residuals, that tells us how far does each point deviate from the regression line on average. How far does each point deviate from the regression line on average? Okay, that is RSC. That's 1.97. So finally, what we can really do is just type summary of model, and we're going to get all these numbers for free. But now you know where these numbers come from. Here we go. Y-intercept, slope. This is huge. This is the y-intercept. This is the slope. We did this already, right? Y-intercept, slope. Boom. 1.937, that's the residual standard error. That's what R calls it. But more specifically, or more exact, standard deviation of residuals. Okay? Boom. R squared, right? R squared is SSR, 1 minus SSR over SST, which is 0.916, and that's what we calculated up here. Okay? So that's that. So that's the numbers. That's how this is what we were traditionally getting our output, but now you know where the numbers come from. We will talk about the standard deviation, our standard error, the t-value, the test statistic, and the p-value later in this course, but you at least know what these values, at least you know what the y-intercept and slope are, and the actual metrics of the model, where they come from. The last thing I would want to do in terms of just having you do some more coding is do scatter plot and work with both of them. So you do x, comma y, comma show residuals is true. Okay, and then show explained is true. Press, you run this, right? This is why I didn't do this earlier. It's because you have to pay look a little closely. So you see the black line denotes the unexplained variability, whereas the green line denotes the explained variability. Okay, you can see how they are partitioned or decomposed in this sense. So you can see both of them at the same time. But you don't have to do both at the same time. Like we did earlier, you can just show one. This should be the black. Okay. So this is just a summary of all the information I've talked about, the SST, some of the squares we're interested. We want to know why each point deviates from the mean. Okay, this is our attempt of trying to explain why they deviate from the means. And this is what's left unexplained. This is how we can calculate the proportion of variability that's explained by the model. And this is how far does each point deviate from the regression line. Okay, key takeaways. You can read that on your own. And that is it. That is it. One of the suggestions that made this video, or made me take so long to create this video, was I was writing this down and drawing the plots. And I think that back in the day, that's how I learned it, and that's what helps as well. So if this was kind of like a lot in terms of R, consider doing that as well. As you're doing it, or at least as you're watching me do it, you draw it out. You write out the explanation. You do the math and see how it connects, and hopefully that helps your understanding. I'm so thankful that you made it to video 3. It's about to be video 4, but all the other videos are long, so this is fine. Have a great day.